What's up? So we're going to go ahead and do these notes for section 10.5. Wow, yeah, 10.5, 10.6. And I'm going to pick up from this point here where we start the corollaries because almost every one of our classes made it through to this point. So this is actually a good spot to go ahead and start. If you need to pick up these notes, just talk to me at any point. So we're going to start with corollaries. Now the corollaries are just a fancy word for extensions or properties of theorems. So based on the theorem that we learned earlier about inscribed angles, right, we learned that the inscribed angle is always half the measure of the intercepted arc. So from there we're going to gain three properties. First off, two inscribed angles that intercept the same arc are congruent. Now what this means for us is this means if I create some inscribed angle, here's the arc that is formed. If I have another inscribed angle that has those same endpoints of the arc, then those two angles are congruent. In this case, I could say this is angle A, and this is angle B. So I would say A is equal to B. It's as simple as that. The second corollary we have is when you have an angle inscribed in a semicircle, and ignore that blank, don't even worry about it. It forms a right angle. And if you remember that a right angle is a 90-degree angle. So let's go ahead and draw a semicircle, which means that I'm going to have a diameter here. So with my diameter, if I draw any inscribed angle that touches here to here, or at any point inside of that half circle, it will always form a right angle. Now the reason this happens is because in a semicircle, this arc is equivalent to 180 degrees. So as a result, half of 180 degrees is 90 degrees. That's why this will always form a right angle. Right over here, the opposite angles of a quadrilateral that is inscribed in a circle, those opposite angles are always going to be supplementary. And supplementary simply means, in case you've forgotten, that they add up to 180 degrees. So I'm going to pick 4 random points inside of here. As you can see, they're not, pre-selected. Connect those two, connect these, and these. Kind of looks like a kite, but little off on that. So these two angles over here add up to 180, as well as these two angles. These add up to 180 degrees. So with these properties that come from the theorem, we can go ahead and apply them to all sorts of different weird shapes. On example 4a, I'm looking at all these 4 numbered angles. Well, right here at angle 1, I'm going to use this green highlighter to create the the chords that form angle 1. And this arc here meets those two. Well, that arc is associated with 70 degrees. If you remember our rule for the inscribed angle, I'm going outside in. So that means angle 1 is equal to 1/2 of the arc measure, which is 70 degrees. So this should be 35 degrees. Now we're going to do the same thing for angle 2. I'm going to use a different color though. I'm going to use blue because blue is awesome. Now for the angle 2, it has this intercepted arc of 40 degrees. Again, I'm going outside in, so we're going to go ahead and say that angle 2 is equal to 1/2 of 40, which is going to equal 20 degrees. So far, not so bad. Now angle 3, I might need to do a little bit of work. However, if you remember the theorem states that if you have an angle that is part of a semicircle, well, here's the semicircle part, and it gets formed with this. Probably help if I used a different color highlighter. Don't worry, we wear pink on Wednesdays. Boom. There's my semicircle. The triangle is inside of there. So angle 3, without doing any work, is 90 degrees. Now angle 4, thankfully that pink is kind of showing up right there, but I'm going to use the Galaxy pen because I know how much you all enjoy that pen. Let's try it a little bigger. There we go. So I want to find the measure of arc 4. Well, if you remember what I said earlier, this is our diameter, which means that it cuts the circle in half. So that means that angle 4 plus 70 degrees has to add up to 180. So therefore, angle 4 is going to equal 110 degrees. Now on letter B, I notice that I have my angle 1, which is formed by these two chords. So the arc I'm looking at is this arc right here. Now I don't have any information about that arc, so I can't really do much. However, if you'll notice that that arc also meets these two different chords, well, those are 38 degrees. And if you remember your property that we stated in the first corollary, two inscribed angles that form the same arc are going to be congruent. So again, without any real work or real hassle, we have 38 degrees. Right here, we're going to find the measure of each numbered angle. Well, if we notice here angle 4 is formed by the intersection of these two chords, and their intercepted arc is this one right here. So to find angle 4, I need to take 60 degrees plus 80 degrees to give me 140 degrees. I'm going outside in, so that means angle 4 is going to equal 1/2 of 140. So that's going to give us 70 degrees. Now angle 2, notice that angle 2 is inside of the circle as well, and it's opposite angle 4. Well, our third corollary states that angles 4 plus angles 2 have to add up to 180. Well, we already know what angle 4 is. So 70 plus angle 2 adds up to 180. So therefore, angle 2 must equal 110 degrees. Now you're probably thinking, wait, Mr. T, we're going to have to do a lot of work for angles 1 and 3. Yeah, we might have to, but corollary 2 is going to help us out because notice that we have the diameter here. And so angle 1 is inside the half circle. So that forms a right angle. But not only that, so does angle 3. Angle 3 is going to be 90 degrees as well. Now the last theorem for this section is the tangent angle theorem, and it technically is a theorem that follows from the inscribed angle, but here's what happens. Instead of having two chords meeting, what happens is you have a tangent meeting a chord, and you're actually going to have the same relationship between the two, but it's going to work a little differently. I'm going to show you how this works. This one is kind of still the ice cream cone property I was telling you guys about, but again, it'll help if we have visuals. So the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. It's the same as the previous one, but here's how it looks. Here's my chord that forms an angle with the tangent line. Use a different color actually. Got my tangent line, got my chord, and the arc that it's talking about is this arc here. So for this case, x is going to equal 1/2 of the yellow arc. And likewise, in the same manner, over here, I've got my chord, and I have a different tangent line, but still a tangent line nonetheless. Here's the intercepted arc, and so then angle x in that case, well, the angle x is still meeting at the intersection of those two lines, so x is going to equal 1/2 of the yellow arc. Now over here on example 6, we're going to go ahead and apply this to our photo. So again, we know that kj is tangent to the circle. We're going to find the values of x, y, and z. So right away, we have a diameter. So this diameter is telling me, hey, this half is a semicircle. Don't keep that highlighted, I'm just showing you. So that means since I have a triangle inside of that semicircle, here's a right angle. So we can actually solve for y right away. We can say that 35 degrees plus 90 degrees plus y equals 180. Doing some calculations, y should equal, why can't I math? 55 degrees. So this will be 55. Now you're probably thinking, okay, where do I go from here, Mr. T? Great question. That's when we got to start thinking about all the ways we can go around the circle. Do you guys see this little chord right here that forms with angle y and the blue line? Well, that's still an inscribed angle. So I'm looking out, and that forms an intercepted arc right here. So in other words, z, angle z is going to equal 2 times the 55 degrees. Remember, we're going from the inscribed angle outward. So inside out, you double out. Who knows, that might have been a cool mnemonic, I don't know. Outside in, you got to take half. So angle z is going to equal 110 degrees. Now we still got some work to do with x, but the nice thing is that x is forming a tangent line. Sorry, angle x is formed with a tangent line here and with the chord here. All I need then is I need to find the measure of this arc. Well, thankfully, I can actually find that arc because that blue line that I highlighted earlier, that's cutting our circle in half. So that means that the pink section is going to equal 180 minus the 110 that we calculated earlier from angle Z. So that's going to give us 70 degrees. So now going back to angle X, X is going to equal 1/2 of that arc, which is 70. So therefore X equals 35 degrees. Moving on, we got a couple more moving pieces here, but hey, nothing you can't handle. Right now I tell you in the directions that RS and TU are diameters. This is going to be crucial for us. And I also tell you that RB is tangent to our circle. We got this diameter here and this diameter here. From here, we're going to go ahead. We're going to use the vertical angle theorem, because then I know this is 126 degrees. Now, since our angles are in the middle, we know that their intercepted arcs are also the same measure. So 126 degrees here and 126 degrees here. Right? Now, we're going to use the fact that the lines are they form supplementary angles. So that means this angle here is 180 minus 126. So that should give you 54 degrees. Likewise, we're going to go back on the opposite side and say this is also 54 degrees. All right. So now, again, our original mission was to find angle BRT. So we need to find this angle. We'll notice that the 54 degrees from the central angle goes to that arc. Likewise, this 54 degrees goes here. So angle BRT, the measure of that angle, is going to equal 1/2 of 55 degrees. Now for this case, because, oh, why did I say 55? I meant 54. Cool. I was going to say, that was a weird thing. Why would I give you that number? So 1/2 of 54 is 27. Next we need TRS. Let's go ahead and use pink. So angle TRS, well, TRS, you'll notice, is an inscribed angle right along R. And you know what? I'm realizing pink is not showing up on your screen as it is on mine. So let's do orange. TRS. Much better. So TRS is that angle right here. Well, the intercepted arc, this one we can use pink, is this one here. Now, because the 126 is on the arc, I'm trying to work in to the inscribed angle. So therefore, angle TRS will equal 1/2 of 126 degrees. So 1/2 of 126, well, that should be 63 degrees. All right, got one more. Let's go ahead and finish strong. Now, I don't give you any other information here besides find the angles. So one thing we can assume for sure is that we do have this tangent line here. The only other thing we have is that 84 degrees. Now, something that I've told you all before is if you have congruent chords, like these ones here, that means their arcs that they contain are also congruent. So what I mean is that these two arcs here are going to actually have the same measure. Now we're going to get to how to find those. In order to do that, we need this 84 degrees. Well, right away we can find W because W is a central angle. 84 degrees is the measure of the arc. So that means W, and why is the iPad not working? Thank you very much. W is going to equal 84 degrees. Now you'll notice that X is in that corner at the edge of the circle. So it forms the arc with 84 degrees, which let's go ahead and highlight that blue. So in other words, X is going to equal 1/2 of that 84. So half of 84 is going to give us a nice 42 degrees. Now angle Y is talking about that intercepted arc, the pink left side. Well, if we remember that 360 is the total sum of all of our measures of the circle. So what I'm going to go ahead and do then is going to do 360 minus your 84. And that's going to go ahead and give us, my brain is fried right now. Well, let's see, 816, so that's 280, 276. So then I'm going to take my 276 and I'm going to split that in half. And that's going to equal the measure of our two sides. So that's going to be 138 degrees. So 138 here. Oh my gosh, that looks like a B. 138 degrees here. 138 degrees here. Therefore, angle Y equals 138 degrees. Now, angle Z, even though it's kind of hard to see, angle Z is our angle formed from these intersections of the tangent lines and the chord. So angle Z will equal 1/2 of 138, and that should give us a nice 100, well, let me try that again, 69 degrees. And there you have it. That was your rest of your 10.5, 10.6 notes. Now, hopefully you're watching this video after you've done your quiz, because we have our CAS testing tomorrow and Wednesday. So just bug me at any time if you have any questions about this lesson. I understand this lesson is not the easiest, and it's totally fine. I understand it. So like I said, with this video, I'm also going to upload my PowerPoint so that you have access to the notes that I did last year, which walked us through step by step. Plus, you'll have this video to hopefully help you. We're not going to be doing anything new until we come back on Thursday and Friday. All right, so until then, stay awesome and steady up, and just make sure you stay on top of these theorems. I cannot express how important it is for you guys to not ignore these. There's a total 11. Like I said, don't just let them slip. Already we've covered 1, 2, 3, 4, 5 in just this chapter. Right? This is basically half of our stuff here. So I got to make sure you guys are very well aware and you know exactly what you're doing. So please, please, please do not hesitate to ask me questions. All right? I'll see you all later. Bye.